and the amplitude of carrier is 50. Amplitude of carrier is 50. Okay, this is AC and this is FC, high frequency, FC. Is simulated by a 3 kilohertz audio signal. Audio means low frequency signal, message signal. Okay, so audio means message signal or modulating signal. Okay, audio, message, baseband signal, all these are same. Baseband signal, message signal, all these are same. Okay, and the frequency for message signal is 3 kilohertz. This is FM. FM is message frequency, FC is carrier frequency, and message 3 kilohertz having an amplitude of 20 volts. This is AM, amplitude of 20 volts. Okay, now sketch the audio signal. First case, first question, sketch the audio signal. So audio signal, and the second question is sketch the carrier signal. First one is audio signal message, so I am putting M of T, and the second I have to make sketch of carrier, so I will put C of T, x-axis, y-axis, origin. We know that message is low frequency signal, message is low frequency signal, and the carrier is high frequency signal, carrier is high frequency signal. High frequency means more number of repetitions, same sinusoidal waveform, but more number of positive negative half cycles, more number of positive negative half cycles from minus infinite to plus infinite, from minus infinite to plus infinite. Okay, and the message means low frequency means less number of repetitions, so you can draw a sine wave in relaxed way, less number of positive half cycle, negative half cycle, and it continues from minus infinite to plus infinite. Okay, first one is message signal, second one is carrier signal. Now what about the amplitudes? You can see in the given question, amplitude is given is 50. So positive side plus 50, negative, this is carrier. Carrier height is given, this is plus 50, and negative side it is minus 50. Negative side it is minus 50. But for message signal, positive side it is plus 20, positive side plus 20. Okay, so negative side minus 20. Positive is plus 20, negative is minus 20. Okay, so this is about the amplitude. Coming to the frequency, carrier frequency is given 75 megahertz. Carrier frequency, FC equal to 75 megahertz. So the time period is inverse of frequency, which is 1 by 75. Based on that, we can write on x-axis. I'm not going into too many details, just to show you the difference, how the message and carrier will be present. More number of cycles, more number of positive negative cycles is nothing but carrier. Less number of positive and negative cycles is nothing but message. Okay, now for message, already given in the question, frequency is 3 kilohertz. So first point, they have asked to sketch the audio signal, completed. Sketch the carrier signal, completed. Sketch the modulated wave. Okay, how the modulated wave will be? If I take x-axis, y-axis, the outer will be similar to a sine wave. Shape of the signal, it will be similar to sine wave. And this is Vmax, and this is V minimum, and it continues on both sides. The shape of this continues on both sides. This is the outer dotted line. What I have done is outer. Inside this is sine, high frequency carrier should be present. Okay, so you can draw it in a more better way. High frequency carrier, outer shape will be similar to the message. Okay, this will continue on both sides, negative side also this will continue, and the maximum height is Vmax, minimum height is Vmin. Maximum is Vmax, minimum is Vmin. Okay, so now determine the modulation index. This is third one, modulated wave. S of t. modulated wave S of t. Now I am going to the fourth question. Fourth question, determine the modulation index. This is first one solution. This is second one. This is third. Now I am going to fourth one. Modulation index is mu and it is AM divided by AC. AM divided by AC. Already AM value given 20, AC value given 50. So 2 by 5, it is 0.4 is the modulation index. Generally, modulation index value will be less than 1 in AM. So it is 0.4 less than 1. Now percent modulation also asked. Percentage modulation. Okay, percentage modulation means multiply with 100. Percent modulation means multiply with 100. So it is 40%. 40%. Now coming to fifth one. Coming to fifth one, write equations for carrier and modulating wave. Carrier wave C of t equal to AC cos 2 pi FCT. Already AC value, FC value given in the question. So I will substitute AC value 50, cos 2 pi, FC value is 75 mega. Mega means 10 power 6 T. This is the equation for carrier. This is the equation for carrier. Now modulating signal, message signal. The equation is AM cos 2 pi FMT. AM cos 2 pi FMT. So AM value is 20. AM value is 20. Then cos 2 pi. FM value given in the question 3K. K means 10 power 3. K means 10 power 3. I am making it as equation 2. This is carrier signal and this is message signal or modulating signal. Message signal or modulating signal. Okay. So it is very easy to have a clear understanding. I have done it. Okay. Message signal means the cycles will be very less. Carrier means high frequency, more cycles. Modulating means the outer will come and based on that the interior carrier high frequency should be drawn. Fourth one, finding modulation index formula AM by AC. Fifth one, equations for carrier and modulation index. Okay, carrier and modulation, message signal, carrier and message signal. Now the next question, you can see the next question. Determine the modulation index and the percentage modulation. Determine the modulation index and the percentage modulation. Okay. So modulation index, we have different formulas. One formula we have used just now, AM by AC. Another formula is Vmax minus Vmin divided by Vmax plus Vmin. If AC, AM are not known, this is the AM signal means modulated signal S of t. AM signal means modulated signal S of t. And we know the shape of the signal and the maximum amplitude is Vmax and the minimum amplitude is Vmin. From this wave also we can calculate modulation index. So this is 80 minus 20 by 80 plus 20, which is 60 by 100 and it is 0.6. Modulation index value 0.6. They are asking percentage modulation also. So multiply with 100, it becomes 60%. Multiply with 100, it becomes 60%. Okay. Now coming to the last question. Coming to the last question. Coming to the last question. An AM signal is demodulated using an envelope detector. AM signal is demodulated using envelope detector. The carrier frequency and the message frequency are carrier frequency 1 megahertz, 1 megahertz, message frequency given 2 kilohertz, 2 kilohertz, carrier frequency, message frequency respectively. The approximate value for the time constant of the envelope detector is approximate value for the time constant of the envelope detector is. Already we have done with the envelope detector where we had the charging time, discharging time. Charging time is Rs into L. Discharging time is RLC, not L, C. Rs into C, RL into C. Charging and discharging time. Envelope detector, this is the circuit, envelope detector. Charging time, discharging time constants. Rs into C, RL into C, and the charging time is very, very less. Discharging time is very high. And FC, FM, we know FC value is higher, and 1 by FC value will be lower compared to 1 by FM. Okay. So now we have to find out what is the RL into C, discharging time value, discharging time value. Okay. So we have the components, circuit is same. We have the components here, and charging time is charging time constant. Charging time constant is Rs into C. Discharging time constant is RL into C, and FC is very high frequency, FM is very low frequency. But if we take 1 by FC, 1 by FM, then this similarity will change. Similarity will change. Okay. Charging time is very less value, and discharging time is very high value. And based on that, Rs into C is less than 1 by FC is less than RL into C is less than 1 by FM. Okay. So already we have FC and FM value. Already we have FC and FM value. So 1 by FC means 1 by 1 mega. Mega means 10 power 6. It is less than RL into C, and it is less than 1 by 2 kilo. Kilo means 10 power plus 3. 10 power plus 3. So this is 10 power minus 6 less than RL into C. Then 1 by 2 means 0.5 into 10 power minus 3. Okay. Now this is 1 microsecond, 1 microsecond, and RL into C, and this is 0.5 millisecond, 0.5 millisecond. So the discharging time is between 1 microsecond and 0.5 millisecond. 0.5 millisecond can also be written as 500 microseconds. 500 microseconds. Okay. And now the value should be between 1 microsecond and 500 microsecond. You can see the options. Option A cannot be the answer because it is not equal to, it is less than 500 microsecond. Option D cannot be the answer because it should be greater than 1 microsecond, not equal to. Now 0.2 microsecond, option C, it is less than 1 micro, so this is also not the answer. Now 20 microsecond is the correct answer. It lies between 1 micro and 500 micro. Okay. So based on the similar, based on the inequality, it is less than, it is not equal to, less than or equal to is not present. It is strictly less than. So we have to take a value from the given options between 1 microsecond and 500 microsecond, and 20 microsecond tallies with the answer.